Hi and Assalamualaikum. Okay, for the assignment 2, we are Group 8. So, for the recyclable material classification by using convolutional neural network CNN. So, this is our group. So, this is me, Muhammad Amir Mambirofi, and two other friends. Okay, this is introduction for CNN. So, this is the image of prelude and the flattened and the full. This is for the CNN. Example image for introduction. Okay, for the introduction in recyclable material classification is the process of identifying and separating different type of recyclable materials such as plastic, paper, metal, and glass. So, a CNN is a type of deep learning neural network that is specially designed for image-based tasks. So, CNN would be trained on a dataset or label image of material which each image is labeled with the type of material it contains. So CNN learns to identify patterns in the image that are useful for distinguishing between different type of material.
Okay, hi, my name is Alvin Sitampadap and my metrics number is CE200100. So today I'll be explaining task 1, which is this is the methodology for task 1. The first convolution neural network CN model must be created to train the data without overfitting or underfitting in order to complete task 1. Next is method required to create the CNN, which is convolution neural network, and then TensorFlow library, which is imported into Google Colab. Then we need to set the input size, width and height are both set to 150 times 150. Then there's 5 convolution block in the model, which is convex 2D and max pooling 2D. This is layer stack are commonly used to define the convolution base. Then photo are rescaled by 1 per 255 because the smaller the input, the better the new CNN works. Then this set of image is taken, which is based on Google Drive data. Later is fed to the model 1 to analyze the outcome and make prediction. So this is the flowchart of task 1. First, we need to connect Google Colab to Google Drive, then feed the specific data from the directory, which is a Google Drive is given. So we need to feed that data to the Google Colab. Then import TensorFlow, create train and validation data directory, then construct a CNN model. Then set the input data specific image size as 150 times 150. Start the training process, plot the output, save the model as M1, then finally feed the image into the model M1 and analyze them.
Okay, for the task 2, DESNet. So DESNet is a type of convolution neural network CNN that utilize dense connection between layers. So DESNet use transition layers to reduce the number of feature map and control the growth of the network. So this is image of example of DESNet. It is a flowchart for task 2. First, we start and import the library, and then connect to Google Drive and analyze the dataset. Then we create the train validation data directory and to get the length of train validation. And then we construct CNN model, construct the pretend model with two model, and then we reprocess the input data and start training in the process and plot the outcome and test image and end.
Now I'll be demonstrating the task 1, and for the task 2, my team member will demonstrate. So now let's go to the demonstration. Hi, my name is Aravindan Sitambadav and my metrics number is CE200100. So today I'll be explaining or demonstrating my task, which is task 1, assignment 1, task 1. So now let's go. So for the first part is need to connect to Google Drive. It means this is a code for the connection for Google Drive. Which is from Google Colab import drive mount. This is the link for the Google Drive. Either you can write link or you can go here to the file. You can press here. Then as you can see here, you can click here and look for the file that you want. So that's all. And then for the next part is you need to Google Colab Drive mounted, so Drive mount connect Drive. The next is feed the specific data from the directory Google Drive. So now as you can see, this is a specific data from the Google Drive, which is I save my file in Vision System. Before that, you need to save your file, I mean the directory file on your Google Drive. It's up to you what title you want to do. So for me, I just put Vision System. So next is you need to import TensorFlow. This is the TensorFlow coding. Then next is create a train validation data directory. So this is a train directory, I mean train directory, then the can train directory and pet train directory. So this is the coding. So next, this is the result. So there's the length 150.310.7713.466.210. The next is train can frame. This is shows features of the uh, uh, train can frame and train pet frame. So next is you need to construct a CNN model. So as you can see, this is the input layer 1530. So then 16 aviation is the convolution, 32 filters, then go on until you will get for 512. Then this is the result. As you can see here, this is the layers, model 1 layers. So this is the result, which is compact 2D and max poly. So next, so this is the total parameters and trainable parameters and non-trainable parameters. Then set the input and data specification where you need to rescale 1 over 255. Then this is the image, because the reason why we are rescaling is the smaller the input, the better the model will work. So next is this is epoch. So we did 200. So this is the 200, as you can see. And next is this is where I get the rendered image. So this is the coding for the rendered image, and you get the image how the Google Colab will read the image. So next is plot the output. So as you can see here, this is the output which I have attain accuracy of 100% and validation accuracy of 99.05. So next is you need to save the model as model M1. So the last part is you need to test the image using this model. As you can see here, before that you need to save your image in Google Drive. So you need to put your name, which is I saved Vision System testing in test one image, and then this is the coding image array. Then print. Then this will detect the image either it's aluminum or bottle, aluminum can or bottle can. As you can see here, this is it checked it. Then for the second image, do as same as before, except the image of the bottle must be backward, behind 15 centimeter between the can and bottle. So as you can see, it also can read aluminum can and one bottle, pet bottle. The next, for third part is exactly the same, but the image you need to bring the bottle in front while moving the uh, can behind 15 centimeter. As you can see, it's still reads it. So that's all for my part. Thank you.
Hi and Assalamualaikum. My name Muhammad Abdurrahman Birofi. Memory number CE200149. Okay, for the task 2, our group do a dance net. So first we open the Google Colab and create a new file. Okay, first we must connect to the Google Collabs to Google Drive, and then we go to the runtime and we change the runtime type, go to the CPU. Okay, first from this we import the our Google Drive, and then connect to Google Drive, and then allow. Okay, after that we import the our Google Drive to our file at this system and recycle. So we need to the train and get aluminium and the bottle. Okay, this the data, the total image length, and then we go to the TensorFlow class. This for the dense net. and then we go DenseNet shape train model. Okay, after that we go to the model train DenseNet to activation ReLU and CMOD. So we get the total parameter, trainable parameter, and then trainable parameters. And then we go to the next step is to flow all image that from the dataset. So this found the image and the class. So then we run the epoch. We set 10 epoch. Okay, after we train the model for epoch 10, so finish. So we import the matplot library. After finish, we get the training and validation accuracy and training and validation loss. Okay, after that, we must test three image that we snap. So we create a file recycle test. So this is picture number one. So this side by side. The pictures number two is the bottle at front, and the second picture is the aluminum can at front. Okay, then we must test one by one. So for the test one, so we can know that the 100% aluminum and 100% of PET bottle can detect. So for the test image 2, yeah, we know that the image consists of 100% aluminum and 0% for PET bottle. And the last one for the third image is the test image consists of 0 aluminum and the for the bottle is 100%. So for me, thank you.
Greetings to lecturer. My name is Parsala KK Ganesan. My metric number is C200184. So today I'll be continuing on the task 2, part 2 for the vision system assignment 2, which is about the VGG16. So at here we have used the Google Colab to carry out the task 2 for assignment 2 of vision system. So the first step is about the connection to Google Drive. So here's the link. The Google Drive is connected to the link, and then all the pictures were inside the Google Drive as well. So step 2 is about feed dataset directory. So here's the step of it we have run. Step 2. Same goes for step 3. Create train and validation data directory. The step 3 have been run successfully. Step 4 is about the import TensorFlow. So these tasks also have been completed. Following that, step 5 is about construct pre-trained model with VGG16. So here's the result. So compared to other methods, VGG have the accurate result. And then here's the pre-process for the input data. Step 6 have been done as well. Then start training process for the step 7. Here's the result for the model fit train generators. And here's the step step 8, which is plot the outcome and get the result in graph. So this is the graph of the training where training and validation accuracy, and this is the graph for training and validation loss. And then step 9 have been executed, which is test with the three images which included in the Google Drive. So the first images was test 1. We save the file as test 1. The can and water bottle have been placed side by side for the first test. And then for the second one, the can have been moved in front and the bottle have been moved behind. So we get a different result. And then the last one will be water bottle in front and then the can is uh, backward, sent backward. So each of the images uh, resulted different results. So following that, the pad stay 15 centimeter in front of the scan. So as we can see here, we can see the distance between the water bottle and then the uh, can as well. So each time it's giving us the accurate result when comparing both the images. So hence the task 2 part 2 of assignment 2 have been completed successfully. Thank you. That's all from us.
For discussion of task 1 and task 2, as you can see, there's three type of model, which is model 1, M1, DenseNet 121, and VG16. So the most best optimal CNN model is with zero training and validation loss, and 100% accuracy in training and validation is DenseNet 121. So that's all for discussion. Thank you. Next, the conclusion for this project. So we created three CNN model which able to perform image classification on recycled material. So from this project, we expose and gain knowledge how object is read and classified by the program model. The next is we use various methodology of control neural network CNN. The architecture almost same, but with a minor modification on the layer and parameters. So based on the assignment and project we did, a DenseNet-121 model as the most optimal CNN model. So as you know, in conclusion, CNN is a powerful tool. So learning and being exposed how to create CNN will always helps us as an engineer, because this type of programming and understanding is used extensively in technology and required a machine to read an image. So that's all. Conclusion. Okay, now for recommendation is increasing the number of training validation data to increase the validation accuracy of the model. Then provide in detailed video and explanation. This is the reason is why helps more understanding of the coding usage of the software. So if we have the video, it's better and it's easier to understand. So the video should has in detail the how we use in Google Colab or any type of software, so that we can understand more.